Alright, time for another DraftPhysics.com, DebatePhysics.com also. Video presentation. Yeah, okay. Part 4. Okay. The other two parts will be up eventually. I mean, part 1 and part 2. In this, whatever, modified form. That apparently so far I can get away with. I should fix my hair. Okay, anyway, fix it. I don't think so. Anyway, on to the video and such. So, continuing where I left off.
The war had caused a massive $2 billion to be poured into nuclear research. People now knew an astonishing amount about the atom and its nucleus.
Alright, so they poured a lot of money into nuclear research. Yeah, seems reasonable.
Specifically, scientists had detailed measurements of how stable or unstable different atomic nuclei were. That stability was a direct result of the battle between the strong nuclear force holding the nucleus.
So again, this strong force doesn't need to exist, and it's even if there wasn't a perfectly good replacement for it, that is just sticking an electron between two protons, even if that didn't exist, it's still just made up. It's just some idea that, okay, we're just going to invent some new force that just pushes protons together. Doesn't push electrons together, doesn't do anything, it just pushes protons together. I mean, it's just, it's made up. It just doesn't have any, it's as unreasonable a theory as dark matter. I mean, come on. Matter that is like all the other matter, except it doesn't have any properties except gravity. I mean, come on. Too silly.
Together and the electromagnetic force pushing it apart. In some atoms, the balance tipped.
So the strong force is just as strong as the electrical force, as you just pointed out, because it's the electrical force that pushes them apart. And so the strong force is just coincidentally the same strength as the force pushing them apart. No.
Towards the strong force, making them very stable. But when the electromagnetic force had the upper hand, they were inherently unstable.
And so the instability just comes from the geometry. There's only so many ways you can stack electrons and protons, okay, and maintain stable relationships.
By the late 40s, scientists began to investigate the implications of the way nuclear stability of atoms varies. They noticed one very strange fact about the nuclear stability of one particular atom.
So now they're going with the middle of the periodic table, iron, and some explanation that this is a transition point where atoms give off energy as they fall apart above iron, and they consume energy to put them together below iron. But they haven't really pulled all these other atoms together. They haven't found ways of necessarily changing, helium into lithium.
Of all the 92 different elements, of the 92 different types of atoms that make up the universe around us, gases like hydrogen and oxygen, solids like carbon and silicon, metals like...
Alright, so it's just silly to talk about solids and liquids and gases because that's all temperature dependent.
gold and silver. One is special. Iron.
So it's just special because of its stability, but I would argue too that the other thing iron has is that the crystals are very flat. It's almost like carbon being able to be diamond or graphite. Those are interesting manifestations of the same atom. And obviously it has something to do with that geometry.
So what makes iron so special? It stems from the unique structure of its nucleus. The 26 protons, along with the neutrons, combine in a very special way to make iron incredibly stable.
So it would be like I said, if you added the neutrons and you just understood those to be protons and electrons, the magic is to have a nice 2-to-1 relationship between the number of protons and electrons.
For some reason, nature has decreed this as the number that allows the strong force and the electromagnetic force to balance each other perfectly. It makes iron the most stable element in the universe. Now we can understand why fusion occurs. Lighter atoms can combine together to become more iron-like. And fission is the opposite process. Atoms heavier than iron can split apart into lighter, more iron-like.
So there are other atoms that are very stable, so I'm just saying that I think obviously the fact is that every atom is built from nothing up. So, you go from hydrogen to helium to lithium, it goes up the scale. And that's how suns build these things. And yes, sometimes they can jump. Okay, so they could take an element of iron and they can combine it with carbon and end up with beryllium or something.
Pieces. So all elements seek the stability of iron. And that fact underpins the whole history of the cosmos.
So I don't see. It's another one of these. That fact is the whole source. That is the meaningful fact. That's the only fact of all the facts you need. I mean, every single fact is the most important fact ever discovered. I don't know if you've seen that in these videos, but it just seems that that's what they keep doing it. Every paragraph has the sentence, well, this is the most important thing that ever happened.
The best way to understand this is to imagine the relative stability of atoms as a couple of graphs. Here's what they show. The very lightest elements, hydrogen and helium, are not quite as stable as they could be. They'd like to be something else, something even more stable. Similarly, the heaviest elements like uranium and polonium are actually unstable. In fact, they're so unstable that they fall to pieces naturally through radioactivity. And here, in the middle, are the most stable atoms of all.
So this chart doesn't really look like that, but you can't see it anyway, so it doesn't matter.
Nickel, cobalt, and iron. So far, so good.
No, I didn't see any of that in that chart, so whatever. So nothing is on the chart until you get to iron, and then there's nothing below that. I don't think so.
Now, here's the amazing bit. This nuclear stability graph turned out to be uncannily similar to a different graph altogether.
Oh, a coincidence. Ooh.
But it was a similarity that no one had ever suspected. That's because data from this other graph came not from the tiny nucleus, but from as different an arena as you can imagine, the vast expanses of space. This other graph came from astronomers who study the blazing light from stars.
It really doesn't look the same, so sorry. You have no sale.
And shows the abundances of the different types of atoms in the universe. By far the most common atom of all is that of hydrogen, followed closely by helium, but not a great deal of anything else. Now look at this, it really is of cosmic significance. Both graphs, the stability graph and the abundances graph, show the same strange but very noticeable peak in exactly the same place. The first scientists who spotted this were...
I don't know what there's... This is all jiggly and going downhill. This is a flat line going nowhere. Who the hell knows what the fuck he's talking about?
Blown away. One graph from the tiny nucleus and the other from the vastness of space point to the same magical atom.
Ugh, brother. So this isn't lining up, the edge of this graph with the edge of that graph. So it's just, this is really reaching, I think. Really reaching. But let's just say that iron is, yes, it's very special.
The atom that provided the key to unlocking the secrets of the entire universe.
Please say it again. The key to unlocking the secrets of the entire universe. Oh, shit, there's so many fucking keys.
Iron, the atom which was the key to understanding the...
It was the key. Say it again. They just keep hyping and hyping.
Atomic nucleus also turned out to be one of the most abundant atoms in the entire universe.
Ah, the entire universe. So again, abundant by what, they say there's more aluminum than iron in the earth, but whatever.
Amazingly, the properties of its nucleus seem to lead directly to how much of it there is. And it's not just true of iron.
Durable means you're going to survive. So yes, atoms are made, and then there's something happens to them that they're either changed into something else, or they're up or down the scale. And so yeah, the more durable you are, it seems like your survival would be increased. Yes, so there should be a correlation between stability and survival. Not hugely surprising.
Radium, which is very unstable, turns out to be incredibly rare. Aluminium...
Well, we know it's not just because it's unstable. We know it's incredibly rare because it's a gigantic nucleus, and gigantic nucleuses aren't as likely to be created. There's no element on the far end of that scale in terms of weight that's incredibly abundant. I don't know about titanium. I mean, that would be a good example of a pretty tough atom. So, but I bet there's not a whole bunch of titanium in the universe.
Which is relatively stable, turned out to be...
I have a piece right here, actually. Yeah. I'll throw in a little personal bit. Little personal stories. So this is my father's titanium. Very, incredibly... A lot of work to hold that up. It's so heavy. This little tiny thing is so heavy. But anyway, so where he worked, they turned titanium into these little beads. It was very hard to do. Anyway, so keepsake of mine and such.
Relatively common. It's a pattern which appears right across the list of elements. The signature of their nuclei is written in the skies above us. And deciphering the meaning of this connection will require the greatest minds of generation.
Can't hear any of this part, so it requires the greatest minds in the history of mankind to put all this together.
The first of these was a rebel and a maverick called Fred Hoyle.
Okay, a rebel and a maverick, Fred Hoyle.
He loved walking the hills and dales of his native Yorkshire.
He liked to walk hills and dales in Yorkshire.
Hoyle always spoke his mind, even though it brought him into conflict with his peers. He became something of a scientific pariah. More than almost any other scientist, he explored the strange overlap between the science of the atom and the science of the cosmos. Hoyle realized what the graphs...
Okay, he still hasn't gotten anything, so, no, well, I'll just wait until he says what Hoyle said.
...revealed is that the underlying theme of the universe was ultimately
change. The underlying theme of the universe is change. Yeah, well, geez, none of us noticed that.
Everything in the universe is in a state of flux. The atoms are trying to gain or lose protons in an...
Alright, so obviously the atoms aren't trying to do anything. And it's just, for the biology, it's just a meat grinder. Okay? And in the big universe, it's still just as circular. The energy is just being spewed out, condensing. In the process of condensing out here, it ends up being sucked back into the core again, just to be spewed out again and condensed. That's all it's doing.
Attempt to become more stable. What Hoyle and his colleagues did was to ask how and where in the cosmos all this atomic transformation, all this alchemy takes place. Hoyle knew that in stars like our sun, hydrogen turns into helium by a process called nuclear fusion.
Right. Now the question again is that really what the sun's doing, or is the sun really just making neutrons? And once you have neutrons and some more protons and electrons floating around, you can make other arrangements. You can build on that.
But could nuclear fusion also be the way all the other atoms in the universe are made? Fred Hoyle's great insight was to work out precisely how the heaviest elements are created through nuclear fusion. Hoyle worked out that this process can only take place at unimaginably high pressures and temperatures of millions of degrees centigrade. In our
Yeah, well, you should just use one temperature scale, you know, like Kelvin or something. Then we could understand.
our universe, there's only one place where such conditions exist. In stars. Fred Hoyle's problem was with the details. To explain how fusion could
See, the bigger the star, the hotter it's going to be, you know, because gravity is creating the heat. And that seems like such an elemental, just a simple deduction. And I don't know why they don't deduce it. I don't know why they think our gravitational pressure stops here on the surface of the Earth. No, every piece of matter is continually pushing on the center of the Earth. We're all smashing it. If it was a bug, you'd be smashing it, okay? I mean, the more mass on either side, it's all going one way towards that center, and it's all compressing it. And that pressure is heat. It can't be converted into anything other than a bunch of motion in both directions. You can't cancel energy. So this is back to the momentums arguments and the kinetic energy theory, that somehow you can actually bang something into something else and you can cancel it. Like this has a 50 and this has a 150, and somehow I can cancel 100 of it and just have 100 pop back out. You can't cancel momentum. And we're given momentum by gravity, and the momentum can't be canceled, so it has to actually jerk matter this way, and then matter gets jerked that way, and then the matter jerks this way, and it's got to keep it moving, and that's the heat.
create atoms heavier than helium was tricky and complicated.
So we know we have really heavy suns in the universe. I mean, really monstrously big ones. 1,000 times the size of our sun. Got to be really hot in there.
Hoyle had to explain precisely how in the fierce heat inside stars, light atoms might fuse to become heavier ones.
So it doesn't seem all that complicated, right? You're just taking these parts that can't quite get pushed together, so they just keep jiggling, and you're just adding more and more pressure until their jiggling gets so tiny in such a tiny amount of space that they are put in a position where they can no longer find their repulsive enemy. So they're so well aligned geometrically that the electrons can't see the other electrons, and the protons can't see the other protons, kind of thing, and everybody feels like they're in the right place. Obviously they don't feel, but
In the 40s, Hoyle worked out that our sun is hot enough to fuse atoms like oxygen, carbon, and nitrogen. But what about heavier atoms like copper, zinc, or iron?
So this all has to be figured out by some formula that I don't think they necessarily have any reason to have any confidence in, because I think it's trial and error will tell you something different. So I'm just saying that whatever their assumptions are about what's possible, I'm sure there's catches to it, where you only need half the amount of heat if they hit each other left-right rather than right-left. It's just like the reflections that Rutherford was seeing, when he shot the alpha radiation. It would make a difference whether the atom the alpha was hitting, the nucleus, was moving away or towards. It would change how much energy was in the impact.
His calculations showed that they could be made inside stars, but these would have to be much hotter than our sun.
So a lot of stars in the rest of the universe are a lot hotter than our sun. So our sun is a medium sun at best. I think it's a little below medium, but whatever. It's not nearly... it's not very big.
And he knew exactly where to find them. These huge bloated stars near the end of their lives were called red giants. astronomers had discovered that there were hundreds of millions of these monsters throughout the universe. Fred Hoyle reasoned that they were hot enough to allow weightier atoms to be fused. But there was still a problem.
Alright, so there was still a problem. So, yeah, I don't know. I don't remember this part. But anyway, it's good you pointed that out because, you know, because it's exactly what I said. But anyway, you know, just verifies my point. Hoyle also agrees that big stars are hotter.
The mighty red giants weren't hot enough to make the really heavy stuff, atoms like gold and uranium.
To make these heavier than iron atoms would mean forcing them to fuse together, becoming more and more unstable. It would require unimaginable temperatures and pressures.
So unimaginable temperatures and pressures. So this is what they say. Now, okay, so whether you need a supernova. So the idea of once it explodes, contending that somehow the explosion is hotter than the sun was, I would argue it doesn't sound quite right to me. Because you're relieving the pressure, right? Relieving the pressure is when you start cooling things down. So like a vacuum, you know, the condensing process or something. Once you allow the gas to expand, well, then it gets very cold very fast. So the idea that the explosion is hotter than the pressure that creates the explosion is almost like saying, you know, you compress a rubber band and somehow there's more energy when the band releases. And, you know, that doesn't make any sense.
His only hope was that somewhere out there in the vastness of space were things so big and so hot they made our sun look like a birthday candle.
And towards the end of the Second World War, during a research trip to Southern California, Fred Hoyle found them.
This is the 100-inch telescope at the Mount Wilson Observatory outside Los Angeles. When it was first built in 1917, it was without doubt the largest telescope in the world.
Let's see, Los Angeles. I'm just trying to think where the eclipse went over now. It'd be more like Mount Washington or something. Okay, never mind. Couldn't use that one.
And it was while he was here, he met up with the great astronomer Walter Baade, who told him about supernovae. Now, these are processes when massive stars explode with an incredible intensity. And in a flash of inspiration, Hoyle realized that here at last were the extreme conditions necessary to produce all the heavy elements.
What Baade was referring to was an explosion of simply cosmic scale.
Right, but the explosion is the release of the pressure. So again, I just can't see how this isn't like you know, cold dynamite and you explode it through a chain reaction. So it's not like this thing is exploding for any other reason than the pressure from the inside is greater than the forces pulling it together. And, you know, it's at an equilibrium while it's hot and burning. And the explosion, again, I'm just going to, you know, I don't see how the explosion creates more pressure. It's not an explosion from the outside pushing in. The explosion's on the inside releasing the pressure.
When the largest stars run out of hydrogen to fuse into helium, they come to the end of their lives, and they collapse under the weight of their own gravity, and then explode outwards.
So I don't think they ever run out of hydrogen. So my argument would be that even small suns, okay, are plenty hot enough to break down helium and into hydrogen. So it's you know, it's making as much as it's killing.
In a blinding flash of inspiration, Hoyle and his colleague William Fowler realized that supernovae might be the hottest places in the universe, hot enough to fuse together even the heaviest of atoms.
So again, I don't see why they think it's somehow acquired more pressure.
Hoyle and Fowler had found the furnaces in which everything was made.
The discovery of how atoms are made in stars is surely one of humanity's greatest achievements. Except for one glaring problem.
There it is again. Greatest achievement, greatest achievement, greatest. It just keeps going on and on and on. Every single frickin' time they tie their shoe. What a great achievement. We just got, we tied our shoe. Great achievement.
Problem. One that Hoyle could never explain away.
Blah, 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 blah.
And it was this.
Okay.
Stellar nuclear fusion can explain how all the elements in the universe are made.
So you really have to, like when you're going to even do the spectral analysis of the sun, you're really, the odds are that the heavy metals, because they are heavier, if they still exist as nuclei, they're heading for the center. They're not sitting on the outside. So their spectra is probably never going to be visible because the photons that would be leaving from them, the vibrations, are never going to get to the surface. So you don't even know what the real composition of the sun is. You don't know what the core's composition is.
Except for two very important ones. The two simplest elements, hydrogen and helium.
In the 1940s, using increasingly accurate equipment, scientists found that a quarter of the sun was in fact helium, which was considerably more than they thought.
So, like I said, they're going to go by some sort of mass, but I still don't. What kind of special instruments? We don't get to know those details. So again, if it's just spectral analysis, you can just surmise that some of that spectral analysis ain't going to do any good. It's like taking the spectral analysis of the Earth. You know it has a crust around it. It's really not going to tell you what's on the inside. The only way you can know what's on the inside is you got to use some other kind of mechanism, sonar or some other kind of penetrating mechanism to find out how much density there is. But it just isn't, it's not really hard science. It's very mushy. And they shouldn't talk about it like, oh yeah, we proved. Or we know for sure.
They realized that to fuse that amount of helium would mean the sun would have to be burning at billions of degrees. But the truth was, the sun only burns at 15 million degrees. The sun just wasn't hot enough to have made all that helium.
So 15 million degrees, what, Fahrenheit? It doesn't say. It's 7,000, I think, Kelvin.
In fact, it turns out that per cubic meter, the sun actually generates less heat than a human being.
Well, the sun is, mostly lighter elements, so that's sort of the catch. It's monstrously huge, 1,000,000 times bigger than the Earth, but the gravity on the surface of the sun is only 25 times the surface gravity of Earth. It's, it's not an outstandingly huge number. 25 is just, it's not 1,000,000 times more gravity. So it's 1,000,000 times bigger, but it's only 25 times the gravity. So obviously it's made out of lighter stuff. Frankly, it's mostly made out of, stuff that's on fire.
So I produce more heat than a piece of the sun the same size as me. This means that the sun is just not hot enough to make all the helium we know that it contains.
There's something wrong with what he just said, right? I mean, that just is... What are you talking about? There's no cold part of the sun. So you really... I mean, it's just kind of idiotic to say that, okay, I'm, radiating at 98 degrees and the sun somehow has an average temperature of something less than that? No, that's not possible. So I don't know exactly how he figured that nonsense, but it sounds like nonsense. I don't think you can scoop up 100 pounds of the sun. You're not going to be scooping up something on fire.
If all the helium wasn't made in the sun, then where did it come from? And even more crucial was the question...
So it came from the same place everything comes from. So the moon is, and the earth, and it's all made out of the same stuff, minerals and all that kind of crap, the periodic table. And that's what the sun ate. The sun ate all the crap. I mean, it was a ton of, look at the moon, all those asteroid impacts. There was a ton of crap in the solar system, and the sun ate it all. So that's what the sun is made out of, is a bunch of this, carbon and all kinds of heavy elements. And the fact is, when they go into the sun, they start turning into light elements. That's what the sun's doing. It's grinding them up so it can make new ones of the same thing. Just like, biology is just doing the same thing. It's just grinding up this pack of atoms and just reforming it in another beastie.
Boyle was in denial about. If all the atoms in the universe started off as hydrogen, where did that come from? All that hydrogen...
So all this crap about where did it come from, these aren't questions you can answer. There's not going to be any trail to that truth, in my opinion. So why bother? Who cares? It's going to be a dumb process. It just doesn't... Go ahead. That's the place where you can make something up if you want to. The Pixies did it or whatever. But just don't make up some theory that something intelligent created this meat grinder.
And all that helium needed an explanation. This problem catalyzed one of the most vicious fights in post-war science. That's because it turned into a much bigger question.
The big fight coming up. Oh, good. It's getting a little bit dull.
In fact, the ultimate question. Was the entire universe created in a single instant, or has it always been there?
So again, I never found this question at all interesting. And so I just don't know why it's so fascinating to other people, because I can't imagine the answer being something really interesting. The answer is just going to be, it was some dumb process. It's just something the universe apparently does. This is whatever reality does. It's stuck with this stuff in it. And that's just the way it is. It has stuff in it. Not for any good reason.
Nearly every post-war physicist was sucked into this controversy, but two men were at its center.
I mean, it's always coming down to the same argument, right? There's just no reason to think there's any kind of reasonable reason, because then you'd have to have a creator for the thing that applied the reason. It would have to have it would have to evolve. God would have to evolve from something if God poofed it. If it was in a simulation, then the people who made the simulation, or the things that made the simulation, they would have to come from somewhere. So it's not an answerable question with anything other than it just is, and it's really dumb. It's a dumb mechanical process. It makes electrons and protons. And then it makes these little bits of force that push them around. I mean, you could speculate that the matter bits are actually force bits that croaked. They hit each other just right, head on or something, and when they do that, they actually cancel, because they get caught just spinning in a circle or something, and that becomes an electron. That kind of thing happens.
One was Fred Hoyle. The other was an eccentric Ukrainian called George Gamow. 6'4", a practical joker, and
all right, Gamble and Hoyt. So this is something I never heard of this big fight. The Hoyle-Gamble fight. Never heard of it.
Refugee from Stalin's Russia. Another physicist said of Gamow, even when he's wrong, he's interesting. Both men would stake their careers on this mother of all physics battles. It all began innocently enough. Gamow had recently been appointed a professor at George Washington University. And
the thriller in Manila and such. Yeah, I don't think so.
Thought the hydrogen and helium riddle might be worth exploring. This was George Gamow's office at the George Washington University. It's really...
So they traveled to all these stupid locations to do this little clip in the guy's office. I mean, really. People interested in physics need this kind of bullshit added? Ugh.
Hokey. It was here that Gamow worked on the problem of why there seemed to be too much helium gas in the sun than could be accounted for from the fusion of hydrogen. Gamow...
He does have a lot of books. So when they do my, this is Gary's room. You're not going to find a book anywhere. Yeah, there's no books. No books.
Came up with the crazy idea that maybe most of this helium had been around before the sun was even formed. This is the moment it gets controversial and leads us inexorably into a row over creation. For Gamow to assert that helium existed in the universe before the sun and the stars were formed, he had to come up with another place that was capable of making helium. Gamow knew wherever this process was, it needed to be staggeringly hot.
I guess I didn't see this part. So, yeah, I guess I fell asleep or something. I don't remember this. So anyway, it's all new to me too.
A searing billion degrees centigrade, millions of times hotter than the sun. At this temperature, matter as we know it is ripped apart. Hydrogen nuclei move about the planet, constantly colliding, making helium at a prodigious rate. But what cosmic event was capable of reaching such an epic, terrifying temperature? To explain this, he used a speculative theory that was doing the rounds at the time.
Alright, so it's the supernova theory, I guess. So supernovas make a bunch of helium. Yeah. I just, like I said, I think the simpler answer that the sun was created not by being just hydrogen. It didn't. It had to. You have to say that the solar system condensed, and what did it condense out of? And I think the argument is it condensed out of a bunch of rocks because that's what we know hit the moon, and so you could argue that it was a bunch of gas that condensed first, but then you got to argue, well, why would the gas condense first? It's lighter, so there's going to be less gravitational force applied, right? I mean, heavy things, because you're multiplying the gravity, you have to take the gravity of the thing being pulled and the thing doing the pulling, so to speak. And so your total amount of gravity is higher for heavier things when two things are in space. So you would think the heavy things would condense first, not the light things. It's a kind of a buoyancy argument in a way. So none of it really works for me. This just sounds like they're telling their story, and I just think their story has a lot of holes in it.
That suggested that the whole universe had been created in a single cataclysmic explosion billions of years ago, a theory that today we call the Big Bang. For decades, astronomers have known that the galaxies are flying away from each other at astonishing speeds. The universe is getting...
So they're astonishing, and that should be a giveaway. How the fuck could all of that matter be moving fast? So I guess they don't have to worry about that question anymore, because now they're saying they're moving away because space is creating more space. So as the photon is coming towards us, a blob of space pops in between the frequency and makes the photon stretch. So that's how idiotic it is. When the easy answer is the photons are traveling billions of light years. We all know there's still some free hydrogen floating around out there in space. It's not complete vacuum. It's close, but it's not a complete vacuum. And over those billions of years, the photons hit some of those atoms. And Compton scattering basically tells you what happens. You lose some frequency. Your light's degraded every time it hits and gets minorly scattered by a hydrogen atom.
Bigger. This means that in the past, the universe must have been much smaller. And in the very, very distant past, the entire universe must have been a tiny, almost infinitesimally minute dot.
So this is all just storytelling, right? They have no good reason to think you can do any of this tiny dot crap. The existence of neutron stars kind of gives you a pretty good blueprint of the idea that, well, you can arrange the matter very efficiently, in the form of neutrons, and basically create something very magnetic. And, that's a good model for creating non-matter, in the sense that it's not going to be in the form of atoms, it's just going to be in the form of a big giant nucleus. I mean, a neutron star is just a gigantic nucleus that's very efficient, so it can be in a very small space. I mean, if it was neutrons, they made the Earth out of neutrons, it'd be the size of a golf ball. So you can make very, very gravitationally strong things out of neutrons. You don't need black holes, you don't need singularities.
And the implication of this is a single moment of creation, an instant at which all matter, even time and space, came into being.
So that the whole idea of saying space came into being and time was somehow created by the Big Bang is it's just nonsense. Distance always existed, and it would always take time to move from one place to another at the speed of light. So again, it's just, they're just creating a whole, they're giving the universe all kinds of attributes for which there's just no evidence any of those attributes ever have or ever will exist. Their whole theory depends on you believing that somehow faster than the speed of light the universe expanded in 1 millisecond or billisecond. It just went from certain size and just poof to 1,000,000 times bigger.
In 1945, most scientists were uncomfortable with this idea, but not Gamow. He spotted that it might solve the mystery of the excess helium in the sun and stars.
Gamow worked out that if the entire cosmos was squeezed down to a tiny dot, it would be immensely hot. In the first few minutes after the creation, the universe would have been hot enough for hydrogen nuclei to squeeze together to make all the excess helium in the sun and stars.
So again, it would be hot before it exploded, not after. The explosion is, as soon as the explosion begins, the cooling process begins, essentially, when you're not confining something in a cylinder of a car or something. If the explosion is free, it's getting colder every millisecond, not hotter.
Now, after those first few minutes, the universe would have expanded and would have been too cool. But a few minutes were all Gamow needed. In that time, all the hydrogen and almost all the helium was made.
So again, they're just presuming that there was something resisting the explosion, that somehow there's a pressure that's building up because of the explosion. There's no pressure. It's free. It can just explode. It's like dynamite blowing up in space or something. There's nothing stopping it, and so it's getting colder the minute it explodes.
That's about 98% of all the atoms in the universe today. Or as Gamow put it, our universe was cooked in less time than it takes to cook a dish of duck and roast potatoes.
So, I mean, this is unfortunate that they turned a subject like what are atoms and how they function, and they've turned it into this mystical crap about big bangs and whatnot, which are just so distant from, really seeing, So they're trying to use a telescope, to see 170 miles away on a round Earth. And it's just not going to work.
But by arguing that the Big Bang, a deeply controversial idea, had created most of the hydrogen and helium in the universe, Gamow ignited an enormous row over creation. Fred Hoyle soon became the most vocal of Gamow's critics.
Fred Hoyle hated the idea of the Big Bang with every fibre of his being. You see, as a committed atheist, he objected to the theory because a single moment of creation to him smacked of a divine creator. Gamow...
I'm surprised by that because, I don't really see that correlation at all. But to me, like I said, the only reason why I find it idiotic is because there's any one of these choices is just as good. An oscillating universe makes just as much sense. The universe condenses a little, stuff contracts, and as it contracts, it's storing heat, right? The sun is an example. It's storing heat as the pressure pushes on it, okay? It takes heat out of the universe. And when the heat's out of the universe, that means the stuff out here is getting colder because it's busy burning the sun. And then as the sun cools, it radiates, so it's giving back that heat. And now there's more stuff on the outside than the inside, so the gravitational pressure increases. So the idea that over billions of years that gravity changes a little bit seems perfectly viable as an explanation to me.
Hit back, saying that without the Big Bang, Hoyle couldn't properly explain why there was so much hydrogen and helium in the universe. Both men had their supporters, and the arguments between the rival camps became quite shrill and personal. Hoyle was deemed as an old-fashioned, crusty old Brit by the Big Bang supporters, and Gamow was condemned as a closet creationist by Hoyle supporters. The arguments raged in scientific conferences.
So again, this really doesn't have anything to do with atoms. It just doesn't.
And in the popular press. Secretly, each side knew that they had a compelling argument, but both lacked the killer piece of evidence that would settle things decisively. The conflict seemed destined to remain unresolved. Then, south of New York, close to the mean streets of New Jersey, an unlikely piece of equipment was to make one of the most important discoveries of the century.
So this part again makes no sense to me. You're saying there was a Big Bang. It means that the light would be the first stuff disappearing, right? It's just like a nuclear explosion. The light comes first and then the other crap is lagging behind. Well, the same thing in the Big Bang. So how can I see any residue of light? It zoomed way past all the matter. It's gone. So unless you're going to argue it's bouncing back off of something, which I think is a viable answer. I mean, I think the universe is a bubble. It doesn't let photons out. They do bounce off the bubble. You haven't advanced your subject any, because there's no way this cosmic background could exist if this was a Big Bang, because the photons are gone. We can't see a photon that's going away from us, right? We can only see one that bounces off of something.
And settle the argument once and for all.
This isn't the New Jersey I know, but whatever. ShopRite. That part's correct. There are ShopRites.
This giant piece of sadly rusting machinery is the Bell Labs horn antenna in New Jersey. It's in fact a radio telescope. But rather than looking...
It's the greatest discovery in the history of mankind. And yeah, they're leaving it outside to turn into shit.
Like the more traditional satellite dish, it has this huge horn-like structure that could be rotated round to face the sky and pick up radio signals from space. It's a bit like a giant hearing aid, but it could pinpoint very, very weak signals extremely accurately. It was originally built for research into satellite communication, but instead it was used in the mid-1960s to make one of the most important discoveries in the history of science.
So they didn't really use it to do the discovery. It was all an accident because it was just picking up noise, and they were trying to find out where the fuck the noise was coming from. And then they figured out, oh, the universe is noisy. So it's not exactly a big surprise, right? I mean, you know, that there would be plenty of radiation in the universe coming from locations we can't see, because there's lots of places we can't, there's lots of suns that are hitting us with photons, but we can't see the sun that's doing it. So it's not a huge surprise. I mean, look up into the sky, you only see whatever, 1,000 little balls of light. Well, there's a ton of photons that are still hitting you from all those other things out there that you can't visually see, but you're still getting hit by the photons.
Two researchers, Arno Pen...
I mean, if our eyesight was better, okay, if we could see single photons, you know, if it didn't take more energy than just a single photon to trigger our vision, if we didn't live in this world full of an awful lot of photons, so obviously we can't, our eyes have to be just as adjusted as a camera, and if you have the aperture wide open and you get way too many photons, then all you get is a white picture. And so it has to filter them out. You have to make the aperture smaller and smaller until you filter out enough photons where you actually see the images. So our eyes are made to see in this world. But if it could see like a photomultiplier sees, well, yeah, then I can point it anywhere up there, and it's going to say, I see photons, I see photons. You know, even the parts that look really black aren't really black. So if we could see, I mean, I'm just saying the night sky maybe be 10 times brighter, who knows?
Penzias and Robert Wilson had got hold of this antenna in 1963 from Bell Laboratories, with the intention of doing research into the faint halo of hydrogen around the Milky Way. Before Penzias and Wilson could begin their experiment, they had to make sure they got rid of all the background noise the antenna was picking up. It's a bit like the hiss on radios in between stations. They spent the best part of a year checking all the equipment and the electronics. They even got down on their hands and knees inside the dish to scrub it clean of what they called white dielectric material, which was basically pigeon crap. But even after all this, there was still a faint, persistent hiss they couldn't get rid of, and it was there whichever direction the antenna pointed. There was only one viable explanation.
So again, there's only one viable explanation. I don't think that's the truth. I think there's other viable explanations. You're just not terribly interested in other viable explanations. That's the simple fact.
The noise was the sound of radiation, the afterglow of Gamov's Big Bang.
So afterglow, how does it afterglow? That's the part I have no way of understanding how the photons, the things moving the fastest, are afterglowing. Now you could say that some of the photons, I guess, hit bigger chunks before they actually left, but they wouldn't have to wait to leave. They would be the first ones out. So, you know, still just doesn't make any sense.
Here at last was final proof that Gamov was right.
Okay, final proof. So that's, you know, he just says there's no other explanation and it's final proof. And that's all you get. Now, you know, there's so many ways you could argue about this. I mean, so every sun that's radiating, we know it's radiating in all directions. And so some of the light is going sideways from our perspective. And it bounces off some other sun. Okay, and it's going to really reflect. The fact is, it's not going to stay in that sun. It's going to reflect off of it, and so it's going to go back somewhere else, and it's going to bounce around. It's going to keep bouncing around in the very space where I just pointed out there's a bunch of hydrogen atoms, and it's bouncing off dirty things, you know, things that have clouds of gas around them. And so, you know, the early solar system, for example, if some piece of light went through the early solar system, it isn't going to come out the other side the same piece of light. Okay, it's definitely going to be a different piece of light. So the idea that you could have a bunch of visible radiation inside the universe that's just bouncing around between the stars, and it never really goes anywhere for billions of years. It just bounces around, and then someday it reflects in our direction and we pick it up as microwaves instead of visible light, because it's been bouncing around for billions of years. So it's just starlight that's really traveled a very long distance before it got to somebody who would say it was a microwave. And even that microwave is going to bounce off of us, and it's going to turn into a radio wave.
The Big Bang had to have happened.
I guess, you know, this is the obnoxious part. I mean, this is not science. This isn't, you know, you're supposed to wait for evidence. You're not supposed to just jump because you see something in the, you know, the Sasquatch suit. And especially in cases where you see the Sasquatch suit and you see the zipper line, then you should have some real doubts. Like 25 times the fuel to go 5 times as fast. it should impose upon you some reason to be a little doubtful that there's such a thing as 1/2 mv squared, because it says something that just can't be frickin' true.
You see, soon after the universe was created, about 300,000 years after the Big Bang, it had expanded and cooled enough for the atoms of the lightest elements to form, leaving the whole universe awash with light.
So why? Why would it be awash with light? Now that's the part that just didn't make any sense. Why would it be awash with light? And why would it be microwaves?
Now, George Gamow had earlier predicted that this afterglow of creation would today be in the form of weak microwave radiation. You can actually hear this radiation as a tiny fraction of the hiss on your radio or TV in between channels.
So again, why did he predict that? How did he predict that? For what reasoning would he give for that? Why? Why would the energy, the light from the Big Bang, be low intensity light? Why wouldn't it be incredibly like gamma rays and shit? Why wouldn't it be intense photons? Why would it be the dullest, low on the spectrum? Why wouldn't it be high on the spectrum? The argument is no, the reason why it's low on the spectrum is because it's damn tired light. And it wasn't from a Big Bang. It's just from all these stars shining all the time, shooting light in directions that always have something in the way. And their light's just ricocheting all over the frickin' place. The fuck?
The detection of this cosmic background radiation by Penzias and Wilson showed that Gamow's Big Bang theory was correct, and that he was right.
So again, it's just correct, right, proof, going, we're finished, we did it, we've solved the problem, it's just such, it's so obnoxious. It's just a religion. It's just a story they tell, and they have, next to nothing as evidence.
About how hydrogen and helium were formed in the early universe. So this, together with Hoyle and Fowler's theories about how the atoms of all the heavier elements were cooked inside stars, gave us the complete picture. We finally
So proof, finished, complete, it's just such a pile of shit. I'm just saying this should be embarrassing in the future, because this isn't going to be the truth. This is all going to be found to be full of holes, full of defects, okay, as a deduction. And it's just going to demonstrate that, scientists weren't smart enough to be scientists. They really didn't understand their job. And their job is to be damn careful before they start saying, we proved. We did it. Like the LIGO morons.
Understood how the atoms of all the elements in the universe were made.
I mean, since I said LIGO, they invented, just like the strong force, they just invented a new physics. Because they figured out, Einstein already told them you'll never see a gravitational wave because it's going to be way too weak by the time it gets to us. And he didn't even think of gravitational waves as being something to do with the collision. He just had the idea that when a binary star is spinning, it's going to have a strong, weak signal. This is going to be a weaker signal than this, gravitationally. When the masses are lined up, it's going to be a stronger signal than when the masses are side to side. That would be the frequency. Okay, so it's like any binary system where one thing is on fire. We see it as a pulsar. We see the light turning on and off because it's being blocked. So it's a similar idea. Well, anyway, it'd be way too weak. Millions of times too weak a signal. Never be able to detect it. And so they had to fix that, right? So after they'd already started making this silly thing, where, they first thought, 2 miles will be enough of a tunnel. And then they really started to do their math and figure out, no, we need more like 1,600 miles. So they're going to have to bounce it off mirrors. So the whole 2 mile thing doesn't mean anything because they're bouncing it off mirrors 1,600 times. I mean, the truth is so far from the story told. But the idea is that, Kip Thorne came up with this little theory that somehow he can convert matter into gravity. So he can convert matter into bent space. So the matter disappears from existence. It's not converted into photons. It's not converted into even neutrinos. It's converted into bent space. So now he can make enough gravity to get to us. But it still doesn't fix their problem. But see, they can't make it into real radiation because there's no evidence in the universe of everything getting hit with this ton of radiation and moving away. So because they don't have any evidence that this explosion causes all of these effects, they have to come up with a fake energy. And the fake energy is in the form of this fake idea that the gravity moves it in and out. So it's not even that the gravitational wave is a pushing wave. It's a pushing-pulling wave. Somehow it has both features. Somehow it has a pull capacity, which, no, it can't. It can just push and not push, but it can never pull. So it's just such crap. They just made it up. They made up a fable to defend it as being a theoretical possibility when, if they had to stay within the rules, like it's a Hawking radiation, just make up a fake radiation. You can't detect it, you can't do anything, so it's just magical radiation. What the fuck is that as an answer?
In less than 100 years, science has performed a miracle.
So just, really slimy conversation talking about a miracle. Yeah, and the miracle is just, just basically lie about the truth. The Eddington experiment was a complete fraud. All right, no credible scientist, in my opinion, nobody who has a doctorate in physics should be able to utter the words that was good science. The guy admits in his own journal 1/10 of the data quality. To get 1/10, it has to be absolute shit seeing. And it wasn't even a 12 noon eclipse. So you're talking about a marginal eclipse to start with. It's a 2 o'clock eclipse. It's not quite, it's not very good. You're looking through a lot of atmosphere. And clearly he couldn't see through the damn atmosphere. 1/10 of the, the data is really bad. And he says right in his own journal, I wouldn't stake my life on these results. And what did they do? They print a New York Times headline saying Einstein proven right. That's not good science. That's crap. That's a religion.
It's a truly
I mean, this is Shroud of Turin science. This isn't fucking science.
Where we come from, and was able to describe the entire 14 billion year history of the cosmos. In the beginning was the Big Bang, an explosion of unimaginable power. In the following 10 minutes, in the searing heat, the nuclei of just 2 types of atom emerged, hydrogen and helium.
Listen to this. Do you think they really know? Oh, 10 minutes. It took 10 minutes. And then when did the magical little poofy thing happen? Where the universe went from this big to, 1,000,000 times bigger in one little poofy moment.
For the next 300,000 years, the universe expanded. At that point, another cosmic chapter began. Individual atoms separated out from each other. As they did this, they released light. It's the remnants of this light that Penzias and Wilson picked up with.
Alright, so they're saying 300,000 years after the Big Bang, that's when all of a sudden everything poofed a bunch of photons for some magical reason. And they ended up being microwaves. For some magical reason. I mean, what a pile of crap.
Then, millions of years after this, massive clouds of hydrogen coalesced into the first stars.
So, again, this idea that the stars are coalescing out of just this, hydrogen, protons floating around, loosely associated with electrons. Bullshit.
In here, they began to fuse, producing starlight, and eventually all the other types.
So you don't produce starlight by fusing an electron to a proton, because they're going the opposite way. The only way you can make light is you have to push out into the universe. You degrade a photon when you push in. You take something of high intensity and you make its frequency bigger when you move away. When my hand moves away, it's red shifting. When it moves towards, it's blue shifting. Now you can't see that, but I'm just saying electrons move a lot faster than my hand. So you could actually, if we could actually see red and blue shift, you'd actually see, when an electron moves, you'd see it turn red and you'd see it turn blue.
Of atoms that exist in the universe today. Our Earth and everything on it, including our own bodies, was forged long ago in the crucibles of space.
Says him, blah, 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 blah.
For instance, my body is almost 3/4 water, which we know is made up of oxygen and hydrogen atoms. We now understand that hydrogen was formed 13 billion years ago, soon after the Big Bang itself. Whereas oxygen...
all that was electrons and protons, okay? The atoms are emergent. They're a byproduct of the function of electrons and protons. The evolution is electrons and protons, neutrons, then you get to atomic nucleuses. And then you get to external electrons and atoms, and then you get to molecules and compounds, and then people.
Had to wait to be cooked inside stars, like our sun. The same is true of another important element in my body, carbon, the element on which all life forms on Earth are based. But my body also contains other elements in smaller amounts, like iron. This element was formed during the dying embers of gigantic stars as they ground towards the ends of their lives.
Yeah, it's too bad we're not made out of iron. Yeah, that would be a lot better, wouldn't it? Yeah. Iron Man.
There are also trace elements, like zinc. There are only 2 grams of zinc in my body, but this element had to be created during a supernova, the explosion of a giant star with cosmic...
Had to be. See, they just keep talking like they have these answers. These are not... This isn't science. This is guesstimation. It's a lot of things, but it isn't really science. Science has got to show a little more discipline. It's got to say things like, we believe, we think it's possible that, something like that, But this, we've proven, we did it bullshit is not science. It's what flat earthers do.
Violence, during which lighter atoms are fused together to form heavier elements. The same is true for all naturally occurring elements. They're all cooked in cosmic cauldrons. Romantically, you could say that we're all made of stardust. But the truth is also that we're all just nuclear waste.
Anyway, so enough. We're not all that radioactive, so the nuclear waste argument probably can be defeated by that fact. By definition, nuclear waste has to be radioactive, So, anyway, that's enough of a video. So, it's number 4. Got the third segment of this to do and such. So, we'll get to that eventually. So, till then and such, and so forth and whatnot.